All right, ladies and gentlemen, we continue with the social epidemiology lecture 2. Here, the lesson focus is basic epidemiology measures. The lesson focus is basic epidemiologic measures, under which we'll be seeing total population birth rate, life expectancy, sex ratio, fertility rate, case fatality rate, and then the second we are going to see measures of disease frequency, and we'll see prevalence, incident rate, risk rate, odd rate ratio. Then we'll see screening issues. Starting with basic epidemiologic measures, under total population, we say that total population describes the number of people in a given community or population. Data can be organized by age, sex, or other characteristics. Total population at risk, which describes the number of people who are at risk for a certain condition of interest, may be more relevant in epidemiological studies. Birth rate. Birth rate is the rate of childbirth per 1,000 people in a given year. The total number of births is divided by the total mid-year population. Life expectancy. Life expectancy is the average number of years a person is expected to live. Life expectancy takes into account average years lived for those in the population. However, the life expectancy at age 1 or age 10 will be different. In Angola, the life expectancy at age 10 is much greater than 38.76 years because it does not count all the children who have died before age 10. In other words, high infant and child mortality lowers life expectancy at birth. Sex ratio. Sex ratio is the number of males to female in a population. For instance, the sex ratio in Angola at birth was 1.05 males on female, meaning there were 105 males for every 100 females. The sex ratio for 65 years or older, however, was 0.76, which means there were only 79 men to every 100 women over 65 in Angola in 2011. Fertility rate. Fertility rate is the number of children a woman will give birth to in her lifetime based on the current age-specific live birth rate. Case fatality rate. Case fatality rate is the number of people who die for a disease or condition divided by the total number of people who have the disease or condition over a certain amount of time. This number can be scaled to be a ratio per 1,000 or per 10,000. Prevalence. Under measures of disease frequency, we have prevalence, which is the simplest descriptive measure for the frequency of a disease or condition. It simply describes the number of people who have a disease at a given point or period in time. Prevalence describes the number of people with a condition at a single point in time, whereas period prevalence may use a span of time such as the number of people with tuberculosis in India during 2002 or between 2000 and 2005. The result is a proportion and is often presented as a percentage. Incidence. It is a measure of disease occurrence in a population at risk over a specific period of time. There are three key parts to this definition. The first is incidence measures only new events of interest. Second, the new cases are measured only within a population that is considered to be at risk of the event occurring. And thirdly, there is always a specified amount of time. We will look at specific examples as we discuss the two different measures of incidence. Cumulative incidence. It is a measure of incidence that presents the proportion of a population of interest that becomes diseased over a specified period of time. In other words, out of a population or community determined to be at risk or candidate for a condition, cumulative incidence measures the number of people who actually develop the condition during the time studied. This measurement is also referred to as incidence proportion and risk because it is a proportion. The results are commonly given in percentages. It is considered to be the average risk of developing a condition over a certain amount of time. Incidence rate. It is a measure of new cases of disease or a condition divided by the percent time of observation. Recall that a true rate includes time in the denominator. Here, the amount of time a person is observed while they are at risk for the disease is part of the denominator. Person time can be understood as the total amount of time the population described in the measurement was followed for the calculation, or the amount of time contributed to the calculation of the rate. Incidence versus prevalence. Both are useful in describing disease frequency, but they serve different purposes. Incidence is useful for studying causes, prevention, and treatment of disease by understanding infection patterns, while prevalence is useful for resources planning because it provides an indication of the disease burden in a population. Risk ratio. It is a measure of risk of a certain event happening in one group compared to the risk of the same event happening in another group. It gives an indication of how likely an event will occur comparing different groups. Odds ratio. Odds ratio is a measure of the risk of disease in the exposed population divided by the risk of disease in the unexposed population, most commonly used in case control studies. It is a number between 0 and infinity and gives an indication of how likely an event will occur comparing groups with different exposure statuses. Rate ratio. It is simply a comparison of two rates of a particular point in time. For instance, the incidence rate of measles in children in one city divided by the incidence rate of measles in children of another city in a given year is the rate ratio. Bias refers to any error that occurs during epidemiologic research that leads to an erroneous association between the exposure and disease. Bias can occur at different stages of the study. There's selected bias, informed bias. Now we look at confounding, which also distorts the relationship between an exposure and disease, but as a result of a third variable. For instance, a study may find that people who carry matches in their pockets have significant higher rates of lung cancer and conclude that carrying match is associated with lung cancer, when it in fact is a third variable that influences both. This mixing of effects makes it difficult to come to causal conclusions in epidemiologic studies because it may be difficult to identify all possible confounders, variables that may influence the exposure-disease relationship. Screening tests are used in public health to test at-risk population for early signs of a disease or condition. They are not meant to be diagnostic, thus positive screens will be referred for further testing. There are many things to consider before starting a screening program, including cost, effectiveness, accuracy of screens, time span of the asymptomatic stage. Validity refers to the accuracy of studies, measurement tools, or results. That is, it describes how likely a statement or measurement reflects the truth. Internal validity refers to the accuracy of an association or causal link, and external validity refers to the generalizability of the measurement or data. Reliability refers to the likelihood of a study to find the same measurements or results in repeated trials. For example, an interview question that receives the same answer from the same respondent at different points in time, assuming the answer is not something that should change over time, is reliable, of course. Statistical significance and confidence intervals are statistical concepts that may also show up in results sections of epidemiological studies. Statistical significance means that a finding is important and that there is a relationship between the exposure and disease. Authors will usually indicate when something is statistically significant either in the text or with asterisks in tables. Confidence interval gives a range of values that most of the time contains the true value you are looking for, such as the or RR. Thank you for following us up. God bless you. Have a nice time while studying our courses. Enjoy and give us feedbacks.